Everybody, and welcome to the fourth Hangout organized within Big Data Europe project. Today we are talking about insight into virtual currency ecosystem by making use of big data technology. And our guest today, and our guest star, is Dr. Bernhard Hasselhofer. He works as a data scientist at the Austrian Institute of Technology, and his research interests lie in finding quantitative methods for gaining new insights from large-scale connected data sets. So welcome, Bernhard. For today's agenda, we will have an introduction about the Big Data Europe project and CESDA and Semantic Web Company as organizers. Then we'll have the main presentation for around 30 minutes, and after that it's Q&A session for 15 to 20 minutes. So I hope you will enjoy it and you will have enough questions for our presenter after everything, after the main part is done. Before we move on, I would like to share some important information with you. So this Hangout is being recorded, and all materials, including summaries, slides, and the recording, will be made available on the Big Data Europe website. And also for our listeners, it is good to use the chat for posting questions. And after everything is done, after the presenting part is done, our team will then read your questions to the presenter and to the rest of the team if that will be necessary. So the team behind this Hangout is, first of all, Martin Kaltenbach. He is CFO of Semantic Web Company from Vienna, Austria, and the Semantic Web Company is a technical partner of CESDA in Big Data Europe project. His colleague, Thomas Turner, also from Semantic Web Company, takes care of all technical aspects behind this Hangout. My name is Ivana Veršić. I'm acting director of CESDA, and in the audience, there is also my colleague Jean-Baptiste Milon. He is Senior Project Manager at the CESDA main office. So once again, welcome to our fourth Hangout, and let's continue with the slides. So just a few words about the Big Data Europe project, which means in the full title, Empowering Communities with Data Technologies. It is a 36 months Horizon 2020 project. It is coordination and support action, and the main goal of the project is to produce integrated stack of tools to manipulate, publish, and use large-scale data resources. As I said, it is a coordination and support action, so it means that it has two measures incorporated within the project. First one is to engage with a diverse range of stakeholder groups which are represented particularly within the Horizon 2020 societal challenges, and there are 7 of them. And CESDA and Semantic Web Company are particularly engaged in societal challenge 6, which means Europe in a changing world, reflective, innovative, and inclusive society. So basically, it is about social sciences and humanities. And the second measure, which is supporting measure, is to design, to realize, and to evaluate a big data aggregator platform infrastructure. So rationale, or the reasons behind this project, why we started this, is to show societal value of big data first and foremost, and then to try to lower barriers for using big data technologies, which are dependent on certain effort and resources, and at this moment limited data science skills. So our main, or the final goal is to establish cross-link or cross-organizational and cross-domain data value chains. So what is big data? We always speak about 3 V's, which is data velocity, how fast is data, data volume, how big is data, and data variety, how different data can be within a certain area. And this is actually the most important V for social sciences and humanities. Consortium is at the moment composed of 18 partners all across Europe, and as I told you, we have to, in the end, to deliver the final aggregator platform for big data for each of societal challenges within Horizon 2020. So you can see here that for each societal challenge we have pilots and then partners who are taking care of that. So as mentioned several times now, for societal challenge 6, there is CESDA, there is Semantic Web Company, and we're working together on that. So Semantic Web Company is our technical partner, then supporting all technical activities. So just to introduce SESDA a bit, we are a consortium of social science data archives, permanent research infrastructures that aims to deliver better access to data, and that should happen regardless of data or researchers' location. And at the moment we have 15 member countries and 1 observer country, which is Slovakia. SESDA is going to become an ERIC, which means European Research Infrastructure Consortium, very soon, within months. And we are actually hoping to get to the level of 18 members at that point. So we are actually widening. What is SESDA doing in Big Data Europe? We are the main representative for Societal Challenge 6, as I told you. And our main goal is to coordinate the societal challenge, of course, and potential users of big data in the field of social sciences and humanities. The other goal is to build interest group, to collect requirements from that group, and to assist our technical partners in the building of big data infrastructure access point for social sciences and humanities on that same platform. So that was in a nutshell, and I would like to actually end here with this presentation. And I would like to open floor for Dr. Haselhofer, so he can take us into the world of virtual currency ecosystem. So Bernhard, the floor is yours.
Yeah, hello everyone, and thanks to the audience for joining this talk, and thanks also to the organizers of Big Data Europe for giving me the opportunity to present our work on virtual currency analytics in the context of this, in my opinion, very exciting project. I think it's a very nice match because today I will show you that we are having a big data problem, and whatever big data platforms, easy to use big data platform that come up in future, can help us in finding a solution is very exciting for us. So since you cannot see me and probably don't know me, just some details about me. Ivan already mentioned, I'm a data scientist at the Austrian Institute of Technology, so this is Austria's largest RTO. My research interests are basically in machine learning, network analytics, and text mining, and usually we're always working together with domain experts on a particular topic. My main focus at the moment is virtual currency analytics, and I'm mostly involved in a national research project called GraphSense, which I will present today. I provide 2 links, graphsense.info and my personal website, if you're interested in more details. So this is my plan for today. Before I can explain how we provide insight into virtual currency ecosystems, I first have to explain what we understand as virtual currency ecosystem under virtual currency ecosystem. So I will give you a brief introduction to virtual currencies and also give you some demos how those systems work. Afterwards, I will focus on our solution. I will explain the goals of our solution and also demonstrate some central features, and afterwards I will focus on the technical aspects of our solution and point out the, let's say, big data components of our solution, and at the end I will give you an outlook on our future work and also point out some, in our opinion, exciting challenges to work on in the near future. So let's get started. First of all, the question, what are virtual currency ecosystems? And before we can answer this question, we actually have to answer the question, what is a virtual currency? Here on the top of the slide, you see the definition from the European Central Bank, which basically says virtual currency is unregulated digital money, which is controlled by some developers and used in some virtual community. There are several definitions out there, and we can argue for some time which definition is right. In my opinion, it's not so important. It's just important to know a virtual currency is just a currency like many other currencies, like the euro or the US dollar. It fulfills the same functions, so you can measure value, you can exchange value, and you can store value. Virtual currencies also have currency codes, like the euro and the US dollar have. So here you see the currency codes for Bitcoin, Ethereum, and Monero. They have currency symbols, and like other currencies, they can just be exchanged with other currencies according to some exchange rate. There is also a classification or a categorization of virtual currencies, and just to point out what I will talk about today, it's important to know that there are regulated and unregulated virtual currencies and centralized and decentralized ones. Today I will focus on those that are unregulated and are decentralized and are based on cryptographic protocols, and the most well-known currency in this case is actually Bitcoin, and so they're also called cryptocurrencies. So what is a cryptocurrency? The main difference between cryptocurrencies and other currency systems like the euro or the US dollar is that in this currency system you do not have pre-assumed identities. That means you can create transactions between so-called addresses, and those addresses have no identities attached. You probably know that you can hardly do this in the real world banking system. In virtual currency system, you can do that. I will show this later. You also have no central authorities or no trusted third parties. So in the real world system, you have national banks who are responsible for money supply. This task is actually taken over by a distributed algorithm and this distributed set of peers, the so-called miners. So money issuance is implemented in a collective distributed way. You also don't need typical payment processors like banks or payment providers, because this is also done collectively. And a central role in this case is take the so-called blockchain, which is a public ledger, a public basically database of all transactions that ever occurred in the entire currency system, and everybody can look at those transactions. Here you have a list of existing cryptocurrencies. You see Bitcoin is the most important one, and in my presentation I will also focus on this one and not the others, but just to give you an impression that the virtual currency ecosystem not only consists of Bitcoin, but at least 647 other virtual currencies. Okay, so now I will briefly explain or give you answers to the questions that usually come up at this point. And the first question is, how do I make a Bitcoin transaction? So in this screencast, you will see my Bitcoin wallet, which is hosted at some Bitcoin wallet provider, blockchain.info, and I will now show you how Bitcoin transactions work. You also see that I'm extremely rich, so I have 0.08 Bitcoins, which is around 80 euros. And now I will, in this demonstration, I would like to make a donation to the Internet Archive in San Francisco, and I would like to donate 5 euros. So what I do is I take their public Bitcoin address, create a new transaction, just paste the address into this field and say, okay, I would like to transfer the equivalent of 5 euros to this address, and it's a donation. And then I just execute the transaction. At this point, you can at this point you also see one of the major benefits of virtual currencies. You can make global transactions with minimal transaction fees in a very very short time. So if you just think, if you want to transfer 5 euros in traditional banking system, it would probably take a week and have a transaction, very high transaction fees associated. So you see global transactions in short time and low transaction costs are really one of the major benefits of virtual currencies, and that's why people use it. Okay, so now you have seen how a transaction works from the user perspective, but how does it work from a technical perspective? So what you have seen before is that I connected to one node in the Bitcoin network, which was in this case blockchain.info. And this node has a local copy of the blockchain in place. The blockchain, as I mentioned before, is just a public ledger, a database of all transactions that ever occurred in the entire Bitcoin virtual currency ecosystem. And when I executed this transaction, this single node actually broadcasted my transaction to the entire Bitcoin peer-to-peer network. Within this peer-to-peer network, you have special nodes who are the so-called miners. They collect pending transactions, and then they try to find a new block. I don't go into the details here, but finding a block is computationally hard, and whoever finds a new block which is valid broadcasts this new block to the entire peer-to-peer network, and the entire and all the peers within this network then synchronize the local blockchain with this new node. That means the blockchain grows over time. Okay, so this is how basic Bitcoin transactions work. The next question that usually come up is how do I get Bitcoins? And one of the most important actors in virtual currency ecosystems are so-called exchanges. Those are services that basically mediate or bring together people who want to buy and sell Bitcoins. So if I would like to buy Bitcoins, I can go to platforms like Bitcoin.de or Kraken, and this platform brings me together with a person who has Bitcoin. So I transfer cash to this person via this marketplace, and the person transfers back Bitcoin to my address. So this is how marketplaces work. And there are actually many marketplaces where you can exchange virtual currencies against real-world currencies like the euro or the US dollar, but also virtual currencies to other virtual currencies. And I just checked the statistics yesterday. There are around 2,650 such markets in place. So exchanges are an important type of real-world actor in virtual currency ecosystems. Another way to get Bitcoin is to use a Bitcoin ATM. So in Vienna, we have a couple of ATMs in the city. You can also use voucher services. So in Austria, for instance, you can go to a tobacco store and just buy Bitcoins by buying a voucher, and then you use this voucher in an online platform to actually transfer Bitcoins to your address. So Bitcoin ATMs, Bitcoin voucher services are also important real-world actors in this ecosystem. The next question that usually occurs is, okay, if I now have Bitcoins in hand, who is actually accepting Bitcoins, and where can I buy stuff using my Bitcoins? And there's an increasing number of merchants and service providers who now accept Bitcoin. Dell is probably one of the most prominent ones. So you can buy your computer at Dell using Bitcoins. Also, Microsoft started playing around with Bitcoins, so you can buy apps, games, and more for your Bitcoins at Microsoft. And many smaller businesses and merchants actually make use of so-called payment providers who provide the service where people can basically pay with Bitcoin, and the merchant then receives the equivalent in real-world currencies. So if you're a merchant and you would like to accept Bitcoin, you don't have to deal with the problem of exchange rates, and you don't have to deal with the problem of setting up wallets. You just handle it via payment provider, and they take care of the conversion. Where else can you use Bitcoin to buy goods or services? And now we're getting into the more shady area of virtual currencies. There are a number of gambling sites out there where you can probably lose your Bitcoins, like this platform Satoshi Dice. So Bitcoin is used heavily for gambling. Even more shadier is you can go to darknet marketplaces and buy illegitimate goods, data, and services. So here you can see there you can buy Rolex for $49, and you can pay with Bitcoin. So Bitcoin is the central currency used by those platforms at the moment. So you see darknet marketplaces are also an important actor in this virtual currency ecosystem. If you would like to camouflage your transactions for whatever reason, you can also use Bitcoin mixing or Bitcoin money laundering services, which basically break up the connection between Bitcoin addresses, which makes it impossible to trace transactions. So this is also an important actor. And all those actors I have shown before somehow make up a virtual currency ecosystem. In this case, the ecosystem for Bitcoin, but the ecosystem can also exist for other currencies. And there are many use cases and reasons why you might be interested in understanding the structure and the dynamics of such ecosystems. And this is exactly why we started our research project GraphSense, which has the goal to provide insight into virtual currency ecosystems. And what we might like to do is that, we first would like to provide the possibility to inspect atomic entities in the blockchain, so blocks, transactions, addresses, currency flows on a microscopic level, so that you can really look into the details. And we also would like to provide the possibility to investigate virtual currency ecosystems from a macroscopic perspective. That means if you would like to understand who are the real world actors in a system and what are the relationships between those actors, you would apply such a perspective. And I will show you later in the demo what this means in practice. But before I go to the demo, just quickly our technical approach, how we would like to provide those two services, those two features. So what we do is we take the data that is available in the blockchain of a virtual currency, in this case Bitcoin, and from this data structure we extract a large graph, the so-called address graph. This graph consists of node and edges, and a node represents a Bitcoin address, so a source or a destination of a payment, and an edge between an address represents a currency flow between addresses. We then also apply clustering algorithms to combine addresses into clusters of addresses, and the idea is that each cluster represents some real-world actor, like an exchange, darknet marketplace, or whatever. Then we also integrate information from external sources, for instance, tags published on some platforms, in order to further understand the details of those actors. Okay, so this is the rough idea. You see graphs and networks and clustering algorithms play a major role in our system from a technical perspective. So now the demo. This is our system. If you want to have access, please drop me an email. And now we would like to inspect the address I just transferred money to. So this is the address of the Internet Archive. This was the destination address of the payment I have just made. And what we see here is a summary of the information that is available in the blockchain about this address. So I have to say this information is not available explicitly, so you really have to crunch a lot of data in order to compute the statistics. But here you can see it in an aggregated way. So here we see that this address has been used in 2,133 transactions, more than 2,000 incoming and more than 100 outgoing transactions. It has been used for quite some time, for more than 3 years, and in total it also has received quite some money. I have to say that here the conversion from Bitcoin to euro is done on a daily exchange rate. So we're using today's exchange rate in order to compute the euro value of the Bitcoin equivalent amount. Okay, here you can see that we can switch currencies, and here in the middle you see a graph. The node in the middle is our focus node, which is exactly this address. All the nodes on the left-hand side represent addresses that are sources of payments with destination our focus node, and those nodes represent destinations of payments where this node has been sourced. The edges here show the number of transactions made between source and destination addresses, and you can also switch views. So now you don't see the number of transactions, but the estimated currency flow between addresses. You can also scale according to different parameters. And one important aspect of the system is, this might be interesting for individual users, but also for institutions, is to see how the currency flows look like in such a system. So you can really expand the path and walk from one address to the other and see how the currency flows look like. Okay, here I'm just showing an excerpt of the source and destination nodes. There are of course many more, but we can hardly display it in our user interface in a way that makes sense to the users. So we provide the opportunity to download node and edge list, which can then be used in other tools like Gephi, for instance, for further inspection. Now I'm coming to an important thing. I mentioned before that we would also like to provide insight from a macroscopic perspective, and this is exactly what this cluster view does. In Bitcoin, everyone can, in theory, create an infinite number of Bitcoin addresses. You can create a new address for each transactions, but there are a number of well-known heuristics you can use in order to combine addresses into sets of addresses that likely belong to the same real-world actor. So in this case, our algorithm actually finds that Internet Archive not only used the one address I have shown you before, but 3 others. And then you of course see the aggregated summary statistics for representing the real-world actor. Yeah, and you can basically apply the same procedures which you can apply on the microscopic level, on the address level. So what you have seen before, green was a single address, and now purple means they're actually each purple circle represents a set of addresses, and this set of addresses can actually be quite large. So in darknet marketplaces, for instance, you have each node can easily represent a set of a few 100,000 addresses. Okay, so this was a very quick overview of the features we provide at the moment. Now I would like to focus more on the technical aspects and explain how we implemented our system. So this is the overall architecture from a conceptual perspective. So what we do is we actually ingest data from external sources, most importantly the Bitcoin blockchain, but also other sources, and we load this data into our data processing and analytics infrastructure, which at the moment is based on Apache Cassandra and Apache Spark. Then we use various handcrafted algorithms to extract an address graph from this raw data set, and then we use anomaly detection algorithms and clustering algorithms in order to compute the macroscopic perspectives. This is the architecture from a different perspective, from a data processing perspective, and it's the architecture we have implemented right now. And this architecture follows a so-called lambda architecture. So what we have here is we have a so-called batch layer, and the task or the purpose of the batch layer is to process a large dump of data. So you can just imagine that we simply dump the entire blockchain into our system and computes the views we need in order to provide the data on the user interface. So this is important to know. We have reached dataset size where you cannot use typical database procedures like joins anymore, because it would be too slow if you want to display the results on the user interface. So what we actually do is we pre-compute as much as we can and store those pre-computed views, the so-called transformed data, into our system. At the moment, we are doing this by using Apache Spark. So we are taking the raw data extracted from the blockchain and other sources and transform it into the so-called target schema. Then we're interested in, at the moment, into a relational database, which provides the backend for our front end. So this is the batch layer. Since we also have the ambition to provide real-timeness, we need another layer, the so-called speed layer. And at the moment, we implement the synchronization actor, which just make sure that the most recent transactions also end up in our system, and computations like clustering are propagated accordingly. You probably noticed that we have a big problem here. The big problem is that we have to implement the whole logic twice, once in the batch layer, once in the speed layer. The reason why we have chosen this architecture was more for practical AIT internal reasons, but at the moment we're actually working on a better solution, in our opinion, which looks like this. So we really would like to merge the speed layer and the batch layer into a single layer and do the batch and incremental processing completely using Apache Spark on top of Apache Cassandra. So we just load our raw data into Apache Cassandra, and we have a Spark-based component watching our raw data sets and then executing the corresponding transformations in order to get those pre-computed views. So we are implementing the entire data transformation pipeline in Apache Spark at the moment, and we expect to release this early or in the first quarter of this year. So you have now seen how our current architecture looks like. Now I would like to focus a bit on the challenges we have ahead. So what we would like to do in the near future is to expand our analytics capabilities also to other virtual currency ecosystems, not just Bitcoin, because there are other ecosystems out there like Ethereum, Dogecoin, Monero, Ripple, Linden Dollar, and many other currencies. And what we would like to do is to provide the possibility to inspect actors and relationships between actors across virtual currency ecosystems, which is quite a challenge because, first of all, we have to deal with quite a large volume of data. So at the moment, and those are the most recent data from our system, we are only looking at Bitcoin and only processing Bitcoin transactions. In a raw form, this dataset is not that large, it's just 91 gigabytes. But as I said before, all the information we need to display on the user interface is not explicitly available as such in the blockchain. So we really have to do quite some computation. And the transformed dataset is at the moment 217 gigabytes. If we put this in a relational database like Postgres, we end up with a database size of 757 gigabyte, which is still not that bad. You could argue that you can handle it on a single machine with lots of RAM. This is what we're doing at the moment. But if you look at the figure on the right-hand side, you see that the number of confirmed transactions just in Bitcoin is really growing. So we know that a solution which does not scale horizontally, like a database-based solution, will hardly work if we want to expand our analytics capabilities for other virtual currency systems. So I mentioned before, there are 646 other virtual currencies out there. They might not have the data volume Bitcoin has, but first of all, it adds up, and second, you don't know how this expands in future. So data volume is certainly a challenge, but I also have to say there are really great solutions out there like Spark and Cassandra, and those solutions allow us to tackle those problems. The second challenge we are facing is certainly variety. So if we would like to include several types of virtual currencies in our analytics procedures, we have to take into account that they differ in their conceptual design. So one data model might or will probably not fit all virtual currencies. So what we really need is some data storage which provides the necessary flexibility to adapt data models over time, because as I said, no data model will fit all virtual currencies, and also protocols change over time. Yeah, the third challenge we are facing, or we will face in future, is velocity. At the moment, it's not so bad because, as I said before, at the moment we're just focusing on Bitcoin, and there we have one block arriving every 10 minutes. So one block is around between 1,000 and 2,000 transactions. But there is this ongoing discussion in the Bitcoin community, and it's very likely that the block size will grow in future. And I also have to say that other virtual currencies like Ethereum, for instance, have a much higher block frequency. So the velocity in Bitcoin is likely to grow, and the velocity in other virtual currency systems is higher. Yeah, so this is the third challenge. And the fourth challenge, and this is actually very specific to our application, concerns computations and analytics procedures on large graphs. So the graph I've shown before, I've just shown a small part of this graph, but actually this graph consists of 212 million nodes, addresses, and at the moment 1.36 billion flows between addresses which are edges. So you can imagine that this is quite a huge graph. So what we need are actually graph algorithms that that provide graph analytics algorithms which work efficiently on large graphs. With large graphs, I mean graphs that do not fit into memory of a single machine, which also leverage distributed computing paradigms like MapReduce. And the last point is very important, also work for large graphs with a skewed node degree distribution. This means a skewed node degree distribution means that a few nodes have many links and many nodes only have a few links, and those are the graphs you typically find in the real world, like in a virtual currency ecosystem as Bitcoin. We also experimented with existing graph computation solutions like GraphX, but I have to say this is exactly where we failed. We have an extremely skewed node distribution, and our experience, at least half a year ago, was that GraphX does not yet work well for this kind of node distribution. So I would say this is certainly something worth to look into in near future. Okay, that's it from my side. I'm now happy to take questions from the audience, if there are any.
Thank you very much, Bernhard. So, hello everybody, this is Martin now from Semantic Web Company from the Big Data Europe project. I'm taking over moderation now for our Q&A session. So one more reminder, you have in your panel, you have a chat feature where we already placed that you can put in your questions there. So we have already received some, but just please feel free to take the chance to put in more of them. And in the meantime, maybe while you type in your questions. So first of all, thank you very much, Bernhard. That was amazing and really, really interesting because we hear so much about Bitcoin and we hear so much about blockchains these days. So I think it's very interesting for the audience, and it was for me to learn more about that and your project. In the meantime, while you type your questions, a few announcements or just information and outlook on Big Data Europe. So you see on the screen the main website where you find all the information is big-data-europe.eu, and here with the link on the mailing list, you can also go into our mailing list and you get a monthly newsletter on big data technologies and Big Data Europe project. And there's one thing I want to point you to, that is the Big Data Europe platform, the so-called Big Data Integrator. Is also available, and all information on the website. And on the 3rd of May, there will be the final BDI release, so with a lot of noise around it, so you can have then also the latest version. Okay, going back to the Q&A session with you, Bernhard, now. So what I have here on my list is a first one, an interesting one. Maybe you tackled it briefly, but the question is Bitcoin itself using also big data technologies these days? Are you aware of that?
I would say no. I mean, what I understand is big data technologies are things like Cassandra, Spark, Hadoop, etc. And Bitcoin is not based on those technologies there. It's based on the so-called blockchain technology.
All right. Thank you very much. So that's very good introduction, because the next question that I have here on the table is about blockchain. And it says that was a very interesting example for using blockchains, but is blockchain technology also used in other domains or other industries these days?
That's a very good question. So Bitcoin came up in 2008 and is based on the blockchain technology. And in this case of virtual currencies, it also makes very much sense to choose such an approach. I often receive the question about possible other application scenarios, so just the question you asked, and they always say, okay, you have to take into account that blockchain technology is also a big hype at the moment. And what I always recommend is to actually really carefully think about the requirements you would like to fulfill with a technology, and then do a sanity check whether or not blockchain-based solution makes sense. And in my opinion, or to our experience, blockchain technology always makes sense when it's not possible to define a central authority. Just in the case of Bitcoin, so they simply didn't want to have a central authority, and where you need a high level of transparency. So in Bitcoin, you can look at all transactions that ever occurred in the ecosystem, so you have an extremely high level of transparency. And this is also important as the third point, when you need a high level of trust. So when I need to trust the system that no one modifies transaction values, for instance, okay, because this is something you typically don't want in a financial system, that someone can simply fake transactions.
Absolutely.
So I think those are the three conditions when it makes sense to use blockchain technology. Here in Austria, we're actually looking at two possible scenarios. One is within the context of the project Data Market Austria. So here we are looking into use of blockchain technology as an asset registry for data sets. because also in this data market Austria, at the moment, the assumption is that we won't have a central authority, and we would like to have a distributed setting, and we would like to have a distributed environment where people can register their data sets. In my opinion, blockchain technology also there provides the exciting opportunity of providing a solution for provenance tracking. So if you derive data sets from other data sets, that you can keep track of it in the blockchain. So asset registry is one interesting use case. The other use case we are looking at the moment are electronic elections. Also there you often have the situation that you might not have a trusted central authority and you need some distributed trust solutions. So there it might also make sense. So those are just some examples. But to conclude this question, so I would say in many situations it does not make sense. So don't start replacing your existing well-running systems in your company, which are based on well-working database technology with blockchain technology, just because it might sound fancy. Just really do the check if it's really not possible to have a central authority, if it's not possible to enforce trust and transparency in another way. If you cannot do it in a central way, then it might be worth to look at blockchain technology for a decentralized solution. So this would be my answer to this question. A long answer, sorry.
Yeah, but a great answer. Thank you very much, because it gives a very good guideline to the audience. What are the 3 important areas if you want to use, or if you have it in place, then you should go for blockchain technology, because I remember in the preparation for this webinar we discussed that blockchain is becoming a very big hype these days, and it's not a solution for everything. So I think that was very important to raise that answer. I have one more question here that is directly on your project, and it says, do you have collaborations with regulatory bodies to use machine learning for following the flow of money? Or how are you doing? I will interpret that also, the flow of money in graph sense.
So first of all, yes, we are working with authorities. For instance, we are working with the Financial Market Authority. We're also in contact with the National Bank, because it's also their job to guarantee financial stability, and of course they're also interested in virtual currencies, and they want to see what's going on there. So yes, we have this cooperation. Regarding currency flows, so we are not using machine learning techniques there, because the currency flows can be computed without machine learning, because you can derive this information from the blockchain. But we are looking into machine learning approaches in order to detect anomalies, anomalous behavior in this ecosystem. So this is where we use machine learning, yes.
Very That's interesting. So you see the outliners then and stuff like that.
Exactly.
That's pretty cool. Okay. Thank you very much. More questions. It's a little bit about big data technology and your use. So a very concrete one is saying, how is data ingested? Are you using special tools for this, like Apache Flume?
We are using, I think, a 20-line Python script.
That is easier for sure.
Yeah. So the blockchain just provides an interface, a REST interface, and we just dump the data into our database.
All right. So when you go ahead and you, for example, ingest in more data sources, then maybe there comes a requirement or a need for an additional ingestion tool. But at the moment it's not needed. Okay.
Yeah.
Mm-hmm. Okay, then somebody is asking you, you showed us the Lambda architecture, or how you're using it. And the question is, I've heard that it all becomes, in these Lambda architectures, all becomes or goes into the direction of using a speed layer only in the recent big data systems. Is that true? Or yeah.
Yes.
But that's not the approach you have taken? Because
it's
you're using
basically,
the batch layer, right?
So we would like to merge the batch layer and the speed layer, so there's just one layer. So this also answers the question. So if you only use this, so it becomes a speed layer only, which also provides the purpose of a speed layer is to provide the real-time aspect, right? And the idea is to do exactly this. And Spark, the recent Spark release has some very exciting feature, which is called structured streaming, which is still, I would say, a bit better. but looks like an interesting, exciting opportunity for doing exactly this. Just providing one speed layer. So the question is right. Yes, this is what we actually want to do.
All right, thank you very much. So we're coming to an end of our question list so far on the session. I have one on my plate because this is a Big Data Europe webinar. So my question is, are you using the Big Data Europe stack, the Big Data integrator already for this, or components, or are you planning to do so?
Actually, we started before you, so the components were not available yet. But just our experience is, so when you work with systems like Cassandra or Spark, it's not so easy. So you really, it's quite tricky to get those systems up and running. And whatever helps us in making things easier, and this is what I expect from Big Data Europe, would be really useful for us. So I'm very much looking forward to your release, and then we can see how to go forward with that. So the question is, the answer is not yet, but hopefully in future.
Thank you very much. So I think that's a wonderful closing statement for our webinar today. So I would like to really thank you once again, Bernhard, for all the insights you gave us into virtual currency ecosystems and how you're making graph analysis and insights or analysis of all this. Thanks a lot to you. Thanks a lot to Ivana, and mainly also thanks a lot to all the listeners, to the audience for today's Big Data Europe Hangout and webinar. And just a final reminder, I think in about 1 week from today, we will publish the recording, and we also will publish the slides that Bernhard has used and Ivana has used today, and everything will be published on bigdataeurope.eu. So thanks a lot again, and have a great day.